So ratio of two IIT standard normal random variables. Let's just say X is normal 0, 1, so is Y. And we want to find the ratio X over Y. Yes. So we know our integral that we derived. It's u times fx of u, fy of uv multiplied by d. Yes. Most common mistake. People would look at, oh, x, y identically distributed, so v has to be 1, which means you have to take statistics all over again. Right? These are random variables, not any two variables. We know the support of x. Standard normal, what is the support? Y, same. And we want to know the density of a standard normal. Which is 1 over square root of 2 pi e raised negative x squared over 2. This is the same for y, just have to change x to y because they are IIT. Now I want to evaluate the density at u. So 1 over square root of 2 pi e raised minus u squared over 2. Multiplied by 1 over square root of 2 pi e raised, for the random variable y, the density would simply be this expression. However, x would be replaced by y. Going to replace that y by uv. I'll have minus u squared, v squared. And d. Root 2 pi times root 2 pi is 2 pi. I can combine those two exponentials together and write it as yes. Bases are identical, you add the parts. Okay, so before we proceed, let's go ahead and look at the limits. So y from negative infinity to positive infinity, x negative infinity to positive infinity. So if I divide those, what should the limits be?
So x equals u, so what would that be negative positive infinity?
Come again.
X equals u, so we would integrate from negative to positive.
So x is equal to u. That would mean negative infinity to positive infinity. And what is y? Did we use x is equal to u? And y was u times b. And we have the ratio of the two random variables.
From negative infinity to y over b.
Y over v. We'll do the limits here. So we want to do a substitution first, right? If we want to integrate. So all of that looks like a constant, right? Or maybe it's better if I just treat that as a constant. Yes. So I don't want to call it u substitution because I have u already. So I'm going to use w. X equal to x. U squared over 2 times 1 plus b squared. Want to take the derivative with respect to, is it u or is it v? U. 2u over 2, 1 plus v squared, multiplied by du. What happens to the 2's?
Wait, should the negative be part of what we're doing here?
Not necessarily. I'm going to keep it when I do the substitution. I'll put that negative out here. I mean, sure, I can bring that in here, but I don't want to. So u times 1 plus v squared du would equal dx. I have u du in the integral, so divide by 1 plus v squared on both sides, end up getting u times du. I'll go back and rewrite the integral. U times du is simply 1 over 1 plus v squared dx. Up there, it is e raised minus x. Good. Now, that is my substitution. The limit for the original integral is from negative infinity all the way up to positive infinity. No matter what I plug in, I'm going to get a positive number. Correct? So the integral over there would have negative infinity to infinity. Because u is from negative infinity to infinity, v negative infinity to infinity, you multiply, they would also lie in negative infinity to infinity. There is a 0, so 0 is a possibility. So the upper limit would be infinity because no matter what you plug in, this will always be positive. So upper limit becomes infinity. 0 is a possibility in our interval, so I'm going to throw in 0 also. Yes. And I'll have 1 over 2 pi, 1 plus v squared, 0 to infinity, e raised minus x dx. Yes. We should know what that integral is. Integral of e raised minus x minus e to the minus x. Okay, after you apply the limits, what do we get? 1. So that would be 1 over 2 pi 1 plus b squared times 1. Basic calculus mistake. So we're going from minus infinity to infinity. So if I split it up, I will write it as 0 to infinity and negative infinity to 0. And when I plug in negative infinity to 0, it'll still be 0 to infinity. Positive 0 to positive infinity will still be 0 to infinity, which means there has to be 2 here. Got it, exactly. And that would result in 1 over pi times 1 plus v squared. What is the support of that? Negative infinity to infinity. Sort of established that over here too. So since it is a ratio, positive number divided by negative number, negative over negative, positive over positive. So it will go all the way from negative infinity up to positive infinity. That is a Cauchy distribution. So the ratio of 2 standard normal distributions is a Cauchy distribution. The location and scale, the location is 0, scale is 1. This is not a regular Cauchy distribution. A regular Cauchy distribution would have beta here, scale parameter. You'd have v minus alpha squared over beta squared. Just like how you have x minus mu over sigma. Same thing. Sigma would come over here, v minus u over sigma squared. We all know where that's coming from. That's coming from the normal, right? Since I have a standard normal, I don't have any location or scale parameters here. But if this were to be mu sigma, then they will pop up.